In today's lab, we will use spectroscopy to determine the rate of a reaction and use that to determine the activation energy. For our experiment, we will use a spectrometer. A spectrometer directs light through a sample. If the sample is colored, it will absorb some of that light, and based on how much light is absorbed, we can determine the concentration of the sample. The first thing you should do when you come to lab is set up a water bath with some close to room temperature water. Allow it to settle at room temperature as you set up the spectrometer. You only need about an inch of water. If you have too much water, your samples may float and tip over. Okay, while that sits, we are ready to prepare the spectrometer. The first thing we need to do is measure a blank. This gives the spectrometer a chance to measure all the light that's given off so that later, when some of the light is absorbed, we can compare to this and see how much light was absorbed. So to do this, fill a cuvette about 3/4 of the way full with distilled water. Check that there are no air bubbles in your sample, and you should always wipe the sides before you measure it with a lint-free wipe. Fingerprints and lint can both absorb light, so it's important to wipe any fingerprints away. Try not to touch the sides too much anyway, and then wipe them away with the wipe before measuring. On the computer, open the Logger Pro software and be sure your spectrometer is connected, and then place the cuvette in the spectrometer and choose Calibrate from the experiment menu. After the warm-up is complete, choose Finish Calibration and OK. Alright, so in our experiment, we're going to be mixing purple crystal violet with clear sodium hydroxide, and then the product will also be clear. So what we'll actually be measuring is how much crystal violet is remaining over time, and that's how we'll determine the rate of the reaction. So all we really need to know is the absorption data at the wavelength absorbed by this purple solution. So to do this, we will fill a cuvette with pure crystal violet. Since it's hard to dry a cuvette, you should first rinse it with your sample 2 times and discard that before filling it with the sample you'll actually measure. I only discarded it once in the video, but 2 is better. This way, any droplets inside your cuvette are your sample, not water, so they won't dilute your sample. Alright, so rinse your cuvette twice and discard with crystal violet, then fill it 3/4 of the way full with crystal violet. Place the sample in the spectrometer and click Collect. Once the spectrum shows up on the graph, click Stop and Store Latest Run. Now click on the Configure Spectrometer Data Collection icon and choose Absorption versus Time. The computer should automatically choose that maximum wavelength for you, and you can click OK. So now you can see in the corner only the wavelength that was chosen, in this case it's 587 nanometers, will be measured, and it will be measured over time to see how the concentration changes. Alright, so now our instrument's totally set up, we're ready to begin the experiment. For the experiment, you will be mixing 10 milliliters of crystal violet with 10 milliliters of sodium hydroxide, and then we'll do the experiment at 4 different temperatures, with room temperature being the highest. So carefully measure exactly 10 milliliters of crystal violet and sodium hydroxide in 2 separate graduated cylinders, and then transfer those samples to 2 separate small beakers. Place the beakers in the water bath and let them come to temperature for about 5 minutes. Measure the temperature of the water bath and record it as your first temperature. Once your samples have come to temperature, be ready to go. You want to repeat this experiment exactly the same way every time, so try to follow the exact same procedure and as soon as you're ready to go, be ready to go. So first, pour one sample into the other and start a timer. Then you can pour the sample back and forth between the 2 beakers a few times to make sure it's well mixed, and then set it in the water bath to keep it at temperature and wait until 1 minute has passed. When the 1 minute mark gets there, quickly rinse your cuvette with the sample and discard, then fill the cuvette, wipe it, place it in the spectrometer, and click Collect. Again, you want to do this pretty quickly. If you take too long, the reaction will already be over before you're even collecting the data. And if you're inconsistent, if you take 2 minutes the first time but only 30 seconds the second time, then your data won't make sense together. So you want to work quickly but accurately. The software is automatically going to measure the concentration at that wavelength for 200 seconds and then stop. So while it's doing that, you can prepare the water bath for your next temperature. You just want to add a few pieces of ice to lower the temperature by approximately 5 degrees. It does not have to be exactly 5 degrees, and don't add too much ice. Remember, a glass of ice water is 0 degrees, so if you add a lot of ice, it'll be way too cold. You'll also need to measure 2 new samples, 10 milliliters of crystal violet and 10 milliliters of sodium hydroxide, and transfer them to beakers and put them in the water bath. Once your data is collected, you can add a column of the natural log of the absorbance. So to do that, choose New Calculated Column, then enter ln absorbance for the name. In the equation edit box, you can enter the ln from the function list and then click the absorbance variable and click OK. Then click on the y-axis label of your graph and choose ln absorbance. So now you're looking at the natural log data. Click the linear fit button and write down the slope as your rate constant k in your data table. Your slope will be negative. You want to record it as a positive number because rate and rate constant are always positive. The reason it's negative is because our crystal violet is decreasing over time. Okay, once your new samples have sat in the water bath for 5 minutes, record the temperature. Hopefully it's still about 5 degrees lower than the first temperature. Repeat the procedure. When you click collect, you'll need to choose store latest run to keep your old data and the graph, and just graph the new data in a new color. This time the graph should automatically make the natural log column and line for you, and so you'll just need to do the linear fit and get the slope for your K. Then you'll repeat it 2 more times until you have 4 temperatures recorded in the 10 to 25 degree range. Once you're done, everything can go into the chemical waste and you're all set.